So you're given this line right here, this shape, and you're asked to rotate it 360 degrees about the x-axis and then to find the volume of that new shape. So to do that, first we'll have to figure out what that new shape will look like. So to do that, you can do that in your mind and visualize how the transformation will take place. But if you can't do that, let me just show you a cool little technique to do that. So let's change perspective. Instead of looking at it from this perspective, let's look at it from the sideways perspective. So you will get something like this if you look at it from the side. So as you can see, on the x-axis I had this red point, which is right here. This is the x-axis. We can't see the line, the x-axis line, because that red point is hiding it. And we have that green point, which is the intersection of those two lines of the triangle, which is right here. And then we have the blue part, or the blue length or height of the triangle, which is represented right here. So now we know it is very easy to figure out what this point is going to do, when it will be rotating around the x-axis. As you can see right here, this is the x-axis, and as it will be rotating, it will create a circle. So we can say that when this will be rotated around, it will create a circle. And then if we join this here, you see that it will create what we call a cone. So let me just use this. So this is not drawn to scale. So we have a cone right here, and we need to find the volume of that cone. So we could use the normal one, the traditional method, which is 1 over 3 pi r squared h. But now let's say that you're given more complicated diagram like this, and you do that rotation thingy, and you get a shape like this, and then you need to find the volume. How do you do that? Well, first of all, let's find the circle. Let's find the area of that pink circle right here. Let's find the area of that pink circle. So the area of any circle is so area is equal to pi r squared. And sorry for my handwriting. So we know that area of any circle is equal to pi r squared, and we know that the radius is represented by r, and in this case the radius is this blue line right here. So now that we have the area of this circle, let's add a little bit of depth in that circle, so that it becomes a very thin cylinder. And we are going to try to find the volume of that cylinder. Oh, damn. So yeah, so we are going to try to find the volume of that cylinder, and then we are going to continue. If only I sorry, my drawing skills are very limited. So here we go. So I have this now I have created this little cylinder right here, which the area is pi r squared. The area is pi r squared, and then the depth is that black part right here. So to find the volume of this disc right here, this cylinder, it's the formula is pi r squared, which is the area of that circle times the height. But what is going to be the height in this case? We know that we are moving on the x-axis, and the height is a small change in x. You see, so we are moving from here to that pink circle to that dark edge. So this is the height, and we can denote the height by something called dx, which means a very small change in x. So we can say that the height is dx x. So now we have the volume of this disk, which is equal to pi r square and then times dx. So now what we have to do is we could just figure out how many disks there are in this we could just figure out how many disks there are in this cone, and then just find all the volume of each individual disk and then add them together. But the problem is that there are an infinite amount of disks like this in this cone. So what we need to do now is to use integration. So let me just give you the point right here. So on the x-axis here is 0, so this is the origin, and we'll set this coordinate to x coordinate to be a, and this x coordinate to be b, right? And we'll define this line by the equation y is equal to let's say y is equal to fx. Let's do it in the general form. Y is equal to fx. So y is equal to fx, the general form of any line, any curve that will be given to you. And now we need to find the volume. So what we could do is to use integral to sum up all of those individual all of those individual disks and cylinders, or cylinders that there will be between the limit b and a. So what we can do is put b here and a here as two limits, and what integral would do is that it will take the volume of each and every disk in those two limits and then add them together. So the volume of the first disk is we know pi r square and then times dx. So pi r squared and then times dx. But now we know that pi is a constant and r is that blue line. But what is that blue line? We'll have to integrate something at the end, because we have that integrate symbol, and we'll have to replace it by those two limits. So what is r? What is the radius of that circle right here? So to find the radius, we are going to draw a line right here. So we're going to draw a perpendicular line right here, which is going to cut the y-axis, and we'll set that coordinate to be y. So we know that the distance between the origin and y is y itself. So we know that this distance is y, meaning that this distance is also equal to y, right? So we have this distance is equal to y. Now we know that y is equal to fx as we've defined it above in the equation. So we can replace y by fx. And you might ask why I'm replacing y by fx. Is because when you will be integrating, you'll be integrating with respect to x, meaning that if there's x in this equation right here, if we replace r by an x value, an x equation, it will be more easy for us. So we now know that the radius of this circle is equals to fx, right? And then if the radius is equal to fx, we have radius to the square here. So radius to the square will equal to fx, and that is to the square. So we know now that we can replace that r with fx. So it will give us something like this. We know that pi is a constant, so we can put pi outside the integral symbol, and then we can integrate between the limit b and a, and then y r will be replaced by r square will be replaced by fx square. So fx and then square and then times dx, and that's where the formula comes from. That's how you derive the formula.